I'm Bill Wake. We're here working on an Elm interpreter. Lately we've been working on operators, but now we're working on function calls. We took a shortcut along the way and didn't really define the type of a return of a function call. So after, when it calls, it returns some type of value. We just said unknown, and we're going to fix that, hopefully today. All right, so I ran tests just a moment ago. All right. So we left off. Enforced function prototype is all variables should pass back variable. So this was some cleanup we did in the parser. So right now we pass back a list of variables or an error expression. And my proposal is I would like to just pass back a list of variables always and take off this optional. And I think we can do this as a pure refactoring. So the deal is if I take this off, it'll tell me I can't pass back nil in some case, which is right here. And we're just going to pass back an empty list. I'm surprised it hasn't complained already. Okay, there we go. It wakes up. I know my computer seems to be running its fan a lot and doesn't, I don't know, can't tell what it is. It's like system processes that aren't happy, but I'm hoping I don't have to declare types on this. All right, and then this one, we already have LHS variables is not nil. So now the calling code, so the calling code has the prototype here, and we're guaranteeing that it's a real value. Now, if it were an error case, let's see, if it were an error case, it would have returned the error already. So, the only time we return an empty list with an error, but that never gets through. When you get down here, you've always got at least one thing in the list. Because it's a definition, it's like function xy equals something. You could say, var equals something. You would still have one variable, and you wouldn't get in here if you didn't have any variables, because this is for definitions. All right. And my hope is this just passes. I don't know if you hear my cuckoo in the background. 3 minutes slow. Okay, we're testing. That should have been warmed up pretty good. Okay. 0.291 seconds. Okay, it took a little longer than that by my watch. But I guess that's what we did. We made parser enforce function prototype is all variables. To pass back a list even if there's an error. Okay. And let's pull that out of our to-do. I guess we're working on function calls today. Right. Okay. Yeah, the heart of the matter, function calls should not return unknown. All right, so that's here. Let's see. So, yeah, right here, we initialize a function call. We say, well, what's his type? I don't know. It's whatever the function returned, and you know. But I think we're reasonably well positioned. Let's run it. So we have these predefined prefix operators like parenthesis plus, and let's see that. That should show us the type, and the type is function goes to from number to number to number, which the arrow is right associative, so it's really number goes to function returning a number, function taking a number and returning a number. But that's the type we want, and the type of plus, so no arguments passed in, is that the type of +3 peels off the first number, and we get number to number. And so we should be able to basically take the function, the first thing we're getting, and the second thing, and peel them off and say, oh, this 3 matches this first parameter number, and what's left is the rest of the type. And if we keep going, +3, 4. Okay, this is the currying thing. You know, we take a function of 2 arguments and pretend, well, not pretend, but make it a function of 1 argument that yields a function, okay? And then we can apply the function to the second argument, and everything's cool. All right, but the good news is I think these types are correct, and they seem consistent. But when you ask our +3, 4 what its type is, it goes like, I don't know. Unknown. Okay, and it's kind of a pain that we're doing this in little 2-hour dribs and drabs, right? I tend to forget what was going on and had to kind of reconstruct my picture a little bit. But the good side is I get time to think about it and not even really study it. It just kind of bubbles around, I guess. I talked yesterday about the idea of abstract interpretation, and the idea there is instead of actually doing the evaluation like we do at runtime with this when we interpret it, we can abstract some feature of the expression and interpret that without committing to evaluating the whole expression. And in this case, the feature we want to evaluate is the types. So can you figure out the types of the functions and arguments even without looking at the values? And I think the answer is yes. I mean, that's what we're relying on for type checking, compile time type checking. Let me give an example. I don't know if you've ever used this thing where you match up units, like if you're doing a physics equation or even just, I don't know, miles per hour and stuff like that, you know. You take away the numbers and you just say, you know, if I have if my car gets 25 miles per gallon and I fill it with 10 gallons, how many can I get? And somebody says the answer is 3 gallons. And you go like, wait a minute. Miles divided by gallons times gallons should equal miles. So you can check the units on the equation without knowing the arithmetic is right or wrong. Okay. I mean, it should be 250, I guess, if I remember my numbers exactly. But the units have to be miles. Miles per gallon times gallons should be miles. All right, and we're kind of doing the same thing in our type checking. So I think, well, this may be more complicated, but, well, what we have is we have a list of expressions, and we know the first expression is a function call, is a function reference or a function of some sort. It's a thing with a function type. And we know the rest of the expressions have whatever type they have. Now, I don't know, there may be some issue in this, but I think what we should be able to do is take the type of the first expression and process it with whatever that means with the type of the second expression, if there is one. So that should give us back a new type. So if my type is function of int goes to Boolean, all right, and I pass in an int, I've got the first argument is function of int going to Boolean. The second argument is an int. I should be able to say int to bool applied to int gives a bool. And so the result should be bool. And if there's more than one, like my plus example, I have plus is number to number to number. I pass in 3, which is a number, and it should apply that to the first one and say, okay, the resulting type of plus of 3 should be number to number, the last two. All right, so this, let's see. This seems to be an operation on types, right? So given a type treated as a function call, if I apply this function to this argument, what happens? Okay, and let's do that there, Elm type. Okay, and I'm just gonna lock this in and close the others and find his test. Okay, and my analogy here is like we did this joint type that computes the matched up type of these things. All right. Now I don't know what we call this thing, but test. How about function application type? It'll get us started. So we're going to make up a type. And let's see if we can find a nice function example. Okay, yeah, here's a generic goes to number. That'll get us started. Okay, so a function takes two Elm types. Let's just go with number, and the result type, I'm going to make a nested. No, let's start easy. Let's say number goes to, and do we have Boolean predefined up here somewhere? Not really. Well, let's go number to float. Okay, maybe this is the toFloat method. Okay, and we're going to define another type. Let argument type equals Elm type.number. Okay, and this is going to be function type. Right. Okay, so our function is number goes to float. Our argument is Elm type.number, and if we say let result equal function type dot apply, I'm making up the name, apply argument type, well, we expect result to be Elm type dot float. Okay, so function of number to float, give it a number, it should get back a float. That seems straightforward. Elm type has no member, apply. Okay, so I think maybe right after this joint type, we'll just make another extension. Elm type. I think I can borrow this. Well, copy is another word for that. We're going to have apply, and this is argument type. Okay, so if you apply to this, What do you get? Well, let's go with unknown for now. Dot unknown. And our test should fail. Okay. One failure, unknown is not float. That's what we'd expect. Okay, now I can just return float. I'm gonna return float. I'm regretting this test is a step too far, so I'm just gonna quickly pass. All right, and I'm gonna make a starter test, a little easier one. Apply only. Apply returns error for non-functions. Okay, so let well, I think I can just do it one line. Let's do Elm type dot float dot apply to Elm type dot integer. All right. Result equals. Okay, so I'm going to say this result should be an error. You're going to make me spell it out? Okay, so if you call apply on something that's not a float, not a function, it should say there's an error. And let's see that fail. Float is not equal to error. Okay. So, all right. Guard. Self equals dot function. I don't know if I can do it this way. Else dot member function is a function. I have to be I don't know if I can do that. No. Okay, let's try it the other way around. If let oh, I know I've done this thing before. If caselet dot name equals token, okay. Caselet dot function of from to equals self. Okay. We'll get it right and then clean it up a bit. All right. So I will leave those for now because we're going to use them in a moment. All right. So if the thing is a function, return float, otherwise return error. Okay, I think that'll get us through. Okay, and then our case, we're generalizing now. So we deal with it has to be a function type to be interesting to us. Okay, if it's not, we want to get this float not because it's the answer, but because it's the 2, and only if this matches. And so I don't know, is that maybe I should do another failure case. Let's do that. Test apply must have first argument compatible. How about has first argument compatible? Has compatible first argument. Eventually I'll get to English. All right, test apply has compatible first argument. That seems legit. Okay. All right, so if we have something from number to float and, well, we pass in, like, we're going to rely on this joint type. I mean, if it's float integer, right, that's definitely incompatible. So let's use that. Number, let's make this thing float to float, and we're going to pass in an integer and get the type, and this thing should be error because that's incompatible. Maybe it's returns error for incompatible first argument. Is that test apply returns error for incompatible first argument? Okay. Float to float, given an integer, applies, and it should be an error. All right. One test with 0 failures. Did it really run that test? It might have, because things go there, but I would have thought the path, yeah, would be float. Okay. I think the little green, the arrow thing was probably just left over from the copying or something. All right. Float to float, you give it an int, it goes like, I don't know, that's incompatible types. We could improve our errors, perhaps, but I'm willing to just roll with it for now. All right. So if well, I think this is the joint type. Okay, so if the joint type is not error, then we should return the 2 type. Okay, if it is an error, if it is incompatible, okay, so if from joint type to argument is an error, we're going to return error. Okay, so from is the first argument, the first part of the function argument type is the one passed in. So in our case, if float joint type with int is error, we'll return error. I think this should pass. All right, and then I think we can generalize this to just return 2. And we'll work in these names. Should pass. All right. So this is the parameter type. And this is the return type. All right, so how we liking this thing? I really feel bad that we couldn't peel off the error first, and maybe there's a way to do it. All right, let's make sure this works. It just renames it, should be fine. Okay, and so we did add elm type dot apply to what would we call this? Process? I don't know. Handle function application to figure out types from function application. Okay, and so I think, you know, from a TDD side, I didn't start at the top of the problem here. I sort of jumped in a level and said, Elm type really should know how to process the function type versus its argument and return the proper type. And now I've sort of got my language, my base layer of stuff is able to do what I need. The risk there is if I went down this path of what I thought apply should be, and I guess wrong, then I've kind of wasted or misled myself in doing this. But I'm pretty confident on this. I mean, this seems pretty straightforward, and it seems to be a good explanation of what's going on. I would love to turn this around though. So how do I look at the type? Well, we could do this, you know, case function and other. I don't know. I'd like a guard. Let's see. Guard. Well, let's do Swift guard statement enum. I don't know. I want one that's a little backwards, so I escape early. Right, so that's a little weird. Usually I use guards like this to I forget what Martin Fowler calls it, but it's an early escape. Okay, so this there's a lot of controversy at one point about, like, is that structured programming or not? Is it, you know, you've got multiple exit points, it's confusing, but it's, in practice, it seems okay. Like, you escape if anything goes wrong, and then you're left with the real work down at the bottom. No, that's not going to help. This is kind of interesting. It's a pretty powerful thing. There's just enough weirdness with these enums. I'm gonna say compare enum ignoring arguments Swift. Well, that's exactly what I want. How to test equality. Ignoring its style. Yeah. Is a number something else? Oh. Can I do this? Can I use a... Oh no, it's an assignment. Equatable will be synthesized. If case equals rank. Oh dear. Card not equals. Yeah. Well, I'm going to try a few things, see if I get anywhere. What I want to do is do a guard clause. Yeah, I guess that's what Martin calls them, right? Lots of other people do too. This is, well, no, I just don't see it. And this is not horribly nested or anything, but it's got a little bit of stuff going on, and it's not helped by my narrow screen. Okay, if the type is function and the joint type is error, return error. It's just having that return type nested in there. I mean, I could flip these two. I don't know, maybe that would be better. And then the error cases all just trail away. If the type is not equal error, then return type, else return error. Right? I mean, that's flipped. Let's make sure that works. And I think I can drop this one and let it fall out. If type is self, type is basically if it's a function. Well, I might be able to do a where clause there. And I guess the let can go on the return the inner values. Okay, and now this should fall through no matter what. If the function type is not function, or if the parameter type is that, then return error. Or a little simpler. And I think I can say where on this. Where this should pass, but I'm going to delete this line in a second. Oh, I got 2. Okay. Okay, now that's redundant, and that's excess. I'll nudge this in a little bit. I almost think if I can get it all the way to that almost is better, but it's too much. Okay, this return. Okay. I don't know if I nudge this over. Maybe to there. Let me pull this back in case you all are screaming at me for code ugliness. No. Okay. That should be equivalent. Maybe I should be relying on their formatting though. Okay. Again, I think, at a normal line width, that's probably reasonable. All right. Well, Elm type dot apply improve conditional structure, something like that. Okay. We're down to one if and one default return or the other. It would be hard to flip this around given that the guard doesn't let me do a case kind of thing, but I think that's all right. And let's get to do back in here. Okay, function call should not return unknown. Well, we're still getting there. I guess what we did was make Elm type apply know how to apply function types. Okay. And so this is that example of abstract interpretation I was talking about. We're stripping out. Normally you have a type, a value, and a type. We're stripping out just the types and working with them at compile time. All right, so our to-do function call should not return unknowns. Now, let's get back to function call. All right, so this thing's returning unknown. I don't know if we're asserting that, but let's get to the function call tests. Wow. It's really bad at guessing what I want to see on the screen here. Okay. Put the test to the right. So do our tests, let's see if any of them return unknown. Nobody may even be looking at this. Unknown, not even looked at. Okay. So we're going to start simple. Variable in. This is probably the closest. Okay. So we're not testing evaluate, we're testing function call knows its result type. Lambda n goes to n, does generic Okay. We get the more specific type from a generic. That's okay. Well, I think we can do operator plus. Well, there's variable plus 42. Evaluate gets 6. Okay, so we can do something like this. Okay. Variable plus integer value of 42. Well, this is interesting because when do we look up that variable? And we're going to get expr dot, I don't know, is it type? Type is going to be equal to well, I think right now it should be elm type dot number. Now maybe the lambda knows its type. Let's see what it's doing. Lambda expression, the type is type function expression dot type, argument type is generic. Yeah, kind of. Expression dot type. Well, a bare variable is going to be generic as well, but I think that's probably okay. Let's call tests. Let's go back. Lambda expression and variable n. Okay, so if you take n goes to n is generic, the type, well, I think we're going to make a, this actually, we're missing a joint type in the return value, I think. Should he be number? Well, I think he should be number because the type of this thing is generic goes to generic because we haven't got a type on n, and generic to integer number should be number, so it should be compatible. But we're going to get the type of this rather than the joint type of that. So I think it should be the joint type. Well, no, that's the from type. See, I don't want to get into generics yet. Let's maybe, well, okay, we're going to give it a think. We're due for a break. Let's take a 2 or 3 minute break. And hopefully lightning strikes while we're on break. Hey, welcome back. All right. I don't know if it's lightning, but I think one thing we could do is instead of returning n, which is generic, let's return float value 1.0. Well, I'll make it 2.0. Okay, just because 0 and 1 you might get accidentally somehow. All right, and what I would hope then is this is elm-type.float. Okay, so we're ignoring the argument and returning the value. Now, I don't know if that's how we handle it right now anyway. So, hey, run the test and find out. But I have a feeling this is going to be generic goes to generic, and it doesn't try and do it. And it is kind of tricky because, like the variable, if I had variable plus like this, like I don't really know the type of the variable. Unknown. Okay, that's from us. Our function call doesn't try and do anything. I don't know if the lambda will know though. All right. Let's get these out and hope we don't need them. Okay. Well, this is we know there's at least one expression, so I don't mind grabbing the first one. But I think we're going to need a helper. Let's extract a method. Oops. A method. I'll call it result type. Move it down. Oh, we can't do that. Well, he can be static. I really like to be able to call functions in my constructor. Thanks for your opinion. I know. Okay, so I'm gonna pass in these expressions. All right, that should be one failure because it's not changing anything. Okay. Okay. Now what we want to do is we're trying to peel off. I mean, this is going to be the first expression exists. Okay. Let function equal expressions dot first bang. We know that exists. Then we want to well, let's say result is expressions dot first. That's not a type though. That's an expression. So type. Okay. Now, so this thing, in our case, this is lambda n goes to float. We expect the type to be generic to float, something like that. Okay. And then so if you just return that directly, that is the result. Okay. Now, I think what we want to say is Well, and eventually I need a loop, but I'm just gonna if I'll just say expressions.count is greater than 1, then I'm going to do something. I'm going to say result equals result dot apply expression sub 1 dot type. And probably have to bang that. Okay. So cannot force unwrap non-optional type. Okay. Surprised it's not complaining. Okay. Let's see. So I get the result type. Generic goes to float. I pass in. I'm going to say that now the result type is if you apply the function to expression sub 1 type, then you get a new type that should be float, and we want to return that. All right. This doesn't handle the arbitrary cases. It only handles one argument. Well, it doesn't even handle that. What do we got here? If it's the right 3 tests, I wouldn't mind. Oh, this test is checking that. Okay. Is it correct? Function call variable plus 345 is not equal to function call variable plus 345. All right. Let's. All right. And how about this one? Number unknown. Well, what do we think should be the answer here? Tuple. Well, Elm type. Find successful. Expected actual. Function call 345 lambda variable x. Yeah, you can see we don't list the types in these function calls in their output. Maybe that would be fine though. I mean, this output of function call is not. That's for our help, not anything defined or anything like that. So let's take his type. We'll see if we can put that in there. Now, I think something's going to be wrong because we're only applying the first one and not the rest of them. But our one test didn't pass. Our test we expected to pass or hoped would pass did not pass. Okay, now I got 4 failures. So somebody else was looking at that string. Okay. Parenthesized may contain function. Okay, now we're getting function call lambda of A is not equal to A. A is just generic. Wow. Why not? Well, this is definitely a tricky one. Function call lambda x float value. He's generic. Well, I think he's coming back generic, which is probably a step forward. Because lambda x goes to x is generic without knowing the type. And so I think that's, let's see if this one passes. Yeah, okay. Now this one, plus 3, 4. Yeah, we just don't handle this case yet. Variable plus 3, 4. I don't know. Maybe we had to figure out this one. Right, the deal is like you define. Well, when we get this, can we rely on the type of that variable? That's the question. The type of variable plus is function goes to blah blah blah. Now we don't handle two arguments, so it may be coming from that. All right, this one, function call plus 4, 5 error. Okay, that's similar. Well, I could move it to error. I mean, right now unknown is no longer going to happen. I think I'm not sure the right way to do this and keep track of it. These cases are a little funny. Tuple, untype, unknown. And I think this is coming back as an error. And it's an error because plus 4, 5, well, we only handle one argument right now. So we would be getting back, in the best case, if it looks up this variable type, the type is number to number to number, and we're only passing one number, so it should be number to number. If we applied the 5, it would work, but we didn't do a loop. Excuse me, we just did a if. I think I'm going to say these are errors for now and see where we are. Again, I think we're back to our original failure. Test as string. Oh, that's even easier. Okay. Function call variable 3, and it's going to be comma error. Okay. Well, yeah. Now, this is one of these cases. So James Shore has these patterns for testing without mocks, and one of the things is instead of hard coding the assumptions about the exact return value, you hard code it in terms of, well, it's not hard coded, I guess. You do it in terms of the pieces that you expect. So instead of error here, I could call expression.type. Okay. And I think that would make it robust against whatever happened in there. And it's sort of right that we're expecting the type, but that's also the expression we're using to get it. So, you know, so it's a trade-off. The nice thing would be if function call changed its format. Function call variable function 3 paren colon space colon. Okay, so if we break it apart by the pieces, then we're we're a little more robust if things change. So if the formatting of expression type, like right now it's parenthesis error, like the parenthesis seems a little weird to me. We put it in just to kind of distinguish it, I guess. But if I decided, no, it'd be better if error just displayed itself directly, then I could change the error's print value and it wouldn't affect this method. So that's the trade-off. Okay, let's keep going on function call tests. Okay, down here. So function call knows its result type, and that part worked. That's good. Now we gotta make something a little more complicated. Well, let's tackle this plus thing and find out what the deal is. Variable plus 42. How about with multiple arguments? Okay. So I don't know where I think it's going to get confused here. Does variable take a type? That would be helpful. Generic. Let's It doesn't seem wrong to me that you would pass in a type with the variable. Like we know this function, this is a function and it's got a lambda type. So let's do that. Let's how about the type equals Elm type dot generic. Okay. And then use that down here. Okay, so I'm giving it a default argument, but I'm saying you should take a type. Do you need a type? Yeah. The type of Elm type. Okay, probably could have inferred that from Elm type.generic, but go. Oh. All right, so I'm saying you could pass in a type to a variable. Let's do that here. Variable this. And its type is Elm type dot function from Elm type dot number. Well, this is going to get complicated, isn't it? It's a number returns Elm type dot function of Elm type dot dot number goes to Elm type dot number. Yikes. Now the formatting here is not helping. Okay, plus takes can I put it here? Okay. It takes a function of number and from number to Elm type dot function Elm type number. This closes that one. This closes that one. That closes the variable. Integer value 4. Integer value 2. Extra argument in call. Function is input and output, both Elm types. What's the issue? Well, let's let the let function type equal this. See if I can express it correctly. Maybe it just hasn't woken up to the fact that I added the generic argument. I kind of suspect that's the case. Okay, yeah, I think that's what it is. All right, so this is integer value. This should be number. Oh boy. Okay, so the type of our function is number goes to function returning or taking number, returning number. Okay, that is the proper type of a curried function. And it's passed in with variable. Okay, and then the two arguments. So right now we just will take, I'm guessing the result type will be elm type.function number to number. All right, so let's run them. All right. Number to number is not number. Okay, that's a good sign. I'll take it. Now, I think in the end, we maybe, those tests that we changed to error probably shouldn't be. We got to figure out something there. But it's, maybe I just need to do this kind of thing in those because the variable, yeah, that's probably what it is. I just need to add this type declaration. Really, it's going to look up this in the symbol table at runtime, but we're not exploring that at the moment. Okay, so this thing now, where's my type function? Okay, so I want to say something like expressions dot drop first gives me, I don't know how it knows that, but drop first. Okay, let's do that. So we're taking our list of expressions, we're dropping the first one, and type int that does not accept a closure. Dot for each. That's all junk. All right, and then now we have an expression coming in here, which is really $0. Okay. Do you pass? I guess that's the first question. Hopefully the test we're working on passes. I don't know about those others. I think they're okay because they don't know how to handle variable type yet. Yay. Okay. Okay, so this is function call propers kind of in quotes. All right, let's work on this. So I think this, what if I take expressions dot drop first dot reduce. Initial result, next partial result. That's what I want. initial result is this. And this thing is a closure. Next partial result is a function from result and expression. In that, the result of that is this. And I think I'm going to return this and comment out this. Have I done that right? Okay. Reduce. We're going to start with expressions first type, and then you're going to combine that with result.apply. All right, let's see. And this is me trying to work on the stream operations and get those in my hands and mind. Yeah, so reduce, the classic one is you'd give it a list of numbers, dot reduce 0, plus. And the 0 is the initial value, and then the plus combines two values. This one we're calling result.apply to get the combination. But it's a little harder to understand, but I don't think it's, I think it's idiomatic. I might just prefer to tab that a little further. Okay. Reduce that with that. Okay. I think that's correct. Now, everybody's passing, but we had those two. Okay, so let's commit this. Use stream operations in function call.result type. Right, let's run. Now, what I don't know is, like, when you do +3, 4, you're passing in variable plus, and what's the type on that thing? I don't think that type is captured. But let's see what happens. Okay, we'll do the same sequence we did. Plus goes to 3, number to number, and then +3, 4. Okay, that's all good. All right. Now let's find those tests. They were in the parser. Elm type error. Okay. That does not, well, So successful parse, like variable plus, okay, let's see what check successful parse does. He creates a parser. He grabs the input. Right. Nobody's looking up that type at this point. Now, we should go see that's something else. We should go see our primitives. All right. Yeah. So we, whoops. We have curry, and it passes in the from to, or type 1, type 2 goes to this, because this is the numeric types. Let's see what curry does with it. Yeah, he makes a function. He makes a proper function. So I think in the runtime, we're getting the proper function. At compile time for the parser, I don't think he can know those things. But if we were to give it these two with the errors, if we were to give plus a proper type, let's take that from here. I hate to repeat. Would it be helpful to have a curry? a curry, like argument 1, argument 2 goes to result type on our Elm type? That would be helpful. Let's do that refactoring. So I would like this, well, I don't know. Sometimes this is obnoxious when you got so many things going on, but let's pull this into a variable. This is argument 1. This one's argument 2. So what I'm doing is I'm pulling out the stuff that's going to be the parameters out of the expression I want to refactor. So this is another variable. This is result type. And these names don't matter a whole lot because I'm gonna pull this whole mess over. Okay, so if I did this and this is Elm types.curry argument 1, argument 2, result type, and it returns a type. So let's extract a method. So you can see my method body has no, it doesn't care what those types are, which is what I want. All right. And I'm going to call it curry argument 1, argument 2, Elm type.function, and I'm going to make it static. And I'm not going to need file private. Okay, because it's going to be public there. All right, this should work. Yeah, okay, function call tests dot curry. Right, that should work. I can re-inline these things. I don't know why I'm taking such small steps here, but I am. It's usually safer. So I'm going to put these back so I don't have an inline in Xcode. Excuse me. Okay, now my function type is curry, these types. That's more plausible to me. All right. And I want to move this over to Elm type. And I'm just going to do it in one step, even though you could break it down. Elm type, yes. And it's kind of like the apply, so I'll leave it here. Static function curry, give it 2 types, and it returns a function of argument 1 to function of argument 2 to result. Okay, that was here. We're calling elm-type.curry. I don't think I can squeeze this in. I mean, I think it's better separated like this. Can do that. All right. Now, where's our parser tests? Let's do the same thing. The function type number to number to number, and variable with the function type. And I'm hoping this, I'm going to leave it like this and hope it breaks. I don't know, that seems weird in a way, but number, 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 variable takes function type. Okay. And we just added that, so it does have a member curry, we hope. All right, let's see what happens. Now, what I want to happen is I want this to break. I want it to say, no, no, it should really be a number, not an error. Okay. Number is not equal to error. Yes. Okay. So this is oops. This is number and number. And just to make these, I just want to make the types different to kind of force and make sure I'm not confused. You know, I don't have the left one confused with the right or anything like that. So I'm going to change this to a float and a number. And then my other failure here, again, it should be number. Yeah, number 5. Okay, and this is number. And again, I'll do the same trick. Well, I'll do that. And here as well. Okay. Now, is there one more? I think that's the check parse method. Okay. Function call, oh, is not equal to 3. Oh, yeah. Okay. .5. Okay. It's actually probably a better test anyway to be mixing types in the tuples, just because they should support that. Oh, dear. Okay, function call variable +34 number 5 is not equal to error. I'm still getting an error. +34 number wait a minute, function call, oh, it's a tuple. Okay, so it's parenthesis in front of function call. Function call is variable +34 of type number and 5.0 is not equal to function call variable +34 error 5.0, which is what we're getting. Oh, why? And is this the same more or less error? Number not equal to error. 3.5, 3.5, function call type number, function call type error. All right. Why? Maybe we don't do stuff right on the tuples. Well, it's coming back with an error. All right. I don't know. They look kind of equivalent complexity. So let's do this one. I guess we really want to stop in function call and see what's going on there. Probably there. Whoops, it was a parser test. Do this. Slow start. Who knows why? All right. So, okay, here we go. Function call. Let's look at our expressions. I wish I could figure out how to zoom this in a little more for you all, but I got a variable name type is function number to function number, I hope. Yeah, so the type looks all right. The string we don't care about, an integer value and an integer value. So this is +34, I think, right? Okay. So storing the expressions is not a big deal. Let's go inside here. Well, this is the downside of that stream. They're a lot harder to debug. All right. Let's see what expressions.firstBang.type looks like. Function to number to function to function. Okay, number to function, which is number to number. That seems correct. I'm gonna wish I had this thing. Now, can I break here? Print result, which should be success. What the heck? Oh, capital R. Result. I know wasn't this. Whoa. It's just not going to know it. Okay. Where am I? Okay, now I can print result. Should be our function thing. Okay, if I take result.apply expression.type, I get that. Okay, that seems good. I'll go. All right. And we're hoping this is applying the for. Expression is for. Expression, whoops. Expression.type should be number. Okay. Result should be number to number. Yes. Result.apply expression.type should be number. Okay. Type number. That seems good so far. All right, let's work our way out. Function call has type number. Looks like it to me. All right, let's go in float value. Well, that's going to have type float. Okay. Elm type tuple. I'm gonna continue. I don't. Okay, that was my expected value. Right. All right. Let's go back in successful parse. Let's print actual. Well, we didn't get there on the parse. We got there. Okay, our expected value built up okay. I'm really kind of confused. Oh, no, I'm not. Well, the deal is this. Let's see. What's function call? I want parser. Yeah, the deal is this plus operator. I'm not sure. I'm not sure if the plus operator, like, do we have that in the symbol table yet, or how does that work? I know we wrap it, so 4 plus 5 turns into function call variable parenthesis plus, which is the prefix function. All right. I don't know if it's in the symbol table with its proper type at that point, or if we use the type. Like, this comes back to, are we looking up variables? Like, how do we get their types? And the only way is, like, they have to know it when they create it, or they have to be in the symbol table. All right, I think we're due for another break, so let's take a couple or 3 minutes, and I don't know. We're gonna have to see. We're gonna have to dig into the plus stuff. All right, welcome back. All right. I guess, if we were content to live with error for now, we'd be okay. And it's kind of like an unknown thing, but I don't think I think we need to resolve this and get these operators straightened out. So let's go back to parser. I guess I can stop this. Well, maybe I should get these passing again. I got changes going on here. All right, let's do that. So Elm type, the first one, this one, error, and this one, error. We think this will pass. Yeah, still doesn't. Function call 3 number is not equal to variable plus 3 4 of number. That seems like the right answer, doesn't it? tuple with number. I don't know, are these... Oh, it is expected actual. Variable +45 error. +45 numbers not equal to 4.5 +45 error. So the actual is coming up with error. Why didn't that work then? Number 5. I'm puzzled. Okay, this is my expected number. How is this? Well, wait a minute. So expected tuple. Okay, I think the type we're getting, the actual type we're getting here, I'm going to comment these out for a moment. Ah, dear. I want to lock in what we got, which is the curry and maybe something else. Let's diff this. I don't know what's going on here. Number flowed. 3 + 4. Okay. Parser tests. Function call tests. At the bottom. We switch to curry. And then Elm type. Yeah. Added curry. Okay. So add Elm type dot curry. And now we got to deal with these parser tests. We'll take one at a time. Why is this? Oh. Okay, tuples with infix expressions. Okay, so the error is the expected is this function called variable with number. That's the result of doing this is not equal to function called variable error. Okay, so it's not so much these types that are blowing up. Oh. Well, our function call variable plus 3, 4 that we parse, okay, the 3 + 4 parsing is not coming up with the right type. So let's investigate. 3.4. Right. So, well, this is down in parser. Let me close other tabs and let's get the parser up. All right, so we're gonna back in these expressions with operators again. Okay, so here's an operator expression. Let's make sure. Well, it seems like tuples are getting their right stuff. Let's take a peek there. Okay, so parenthesized expression. Expression, left paren, parenthesized expression. Yes. Okay, so this can be expressions, comma, expressions. It could be a tuple, in other words. Operator expression, get operator expression. So we are processing operators in those. I think that's what those tests drove out. But I think our case, now maybe we just have a simpler case. Let's find one that's just like 3 plus 4. Well, that's one. Function call. Let's stop. Let's stop here. Okay, and we'll step in. Oh, don't want to do that. We'll step in here. Okay, and over here, parser equals parser.input. Okay. Step over that and in here. Let's get to the parse. Okay, so we have +3, 4. Can start expression, function caller definition. Yes. Okay. And this is parenthesis +3, 4. So it's really just operator expression and in. Okay. We're going to collect a list of expressions. So let's do this. We'll skip down here. Okay. Now let's look at result. This should be our +3, 4, I think. Okay, it's a Whelm expression type error. 3 values. Expressions is 3 values. Generic. Okay, that's a problem. I mean, that's the problem right there. So we parse it, we get the generic function, we just get a generic, it's not even a function, and we say apply generic to 3, and it says, what are you talking about? You're not a function, you don't get to apply. Excuse me. All right, so at this point it's too late. The operator has the wrong thing. Okay, so let's try that again. Did I leave enough breakpoints? I hope. Maybe I didn't. Okay. Let's get into parser. Operator expression is expressions. Token can start expressions. Expression, token, int, float, lowercase name, prefix operator. All right, let's go here. Yeah. Well, I see there's no mechanism at all that would put put any types on plus here. Why does it work? Oh, at evaluation time it works because we've built up a symbol table that has this in it and links to our queried functions. But at compile time, or parse time, I should say, it does not. Okay, did I break here? Yes. Okay. Right, we'll continue. Okay, so print name should be plus. Yes. Okay. And we return variable name, but notice we don't have any types on it. And I guess what I'm coming to is, is this saying that we need the symbol table pre-filled to do the operations correctly, right? Because otherwise we just have parentheses plus parentheses. There's nothing that tells us that it's, number to number to number. We just threw in and said, oh, it must be generic, which it sort of is, but like the point where it looks it up at runtime, and this is where I'm struggling a little. We got compile time or parse time where we're finding out like, oh, here's this thing, you're going to build up a function call and all that stuff. We would like that function call to reflect the types of stuff going on because we're trying to type check it while we build it. And then at runtime, everything's supposed to be all type checked and just, plug away. And yet we're running into this thing that we're using variables. Oh boy. Yeah, we're using variables and we don't know their type. And that can't be completely right. But what I wonder is, like, when you redefine things, we're going to go to the REPL. All right, so if I say x equals 3, function of y equals x plus y. Now, it should say, oh, no problem. If I say x equals false, now I'm changing x. Does that change this? Well, interesting. It is clearly doing some sort of analysis here, right? Because I assigned x and it says, wait a minute, I'm looking around. I see I've got something that uses x and you don't have a legitimate use of it. Let's do g of y equals x plus y. X is number. Number goes to number. Okay, so it's still assuming numbers. And let's do x equals 3.0. Everything's happy. X equals 4. Everything's happy. X equals false. I bet it complains about both. No, just the one. X value is 4 still. Well, it certainly seems to know that there is a function. It's almost like somebody's got the dependencies and says, I defined this function. It's got a free variable. Therefore, it depends on the environment to get it. Now, it may be the REPL's a little weird because, these are not being treated as immutable things, but I think the bottom line of this, though, is like clearly it knows plus is actually it knows it's prefix plus, and it only works with int or float because it's number to number to number. That tells me our parser needs access to our symbol table, at least for these operators, and maybe for user-defined types too. But we'll save that one. But operators are clearly in the symbol table when it's looking at this stuff before it does any. It's not evaluating G yet. Okay, we can. G of 55 is 59 because X was 4 and that is number. And if I say X equals 3, G of 55 should be 1 less, right? Okay, so we need to add those, unfortunately. Woof. But variables, yeah, well, we'll see what happens. All right, so let's go look at our interpreter. We'll stop this. So interpreter here, symbol table, I don't know what the nil is, but here's all our prefix primitive operators. That tells me our parser needs something like this. Oh, nil is the previous table. So yeah, there is no previous table. Right. So this test is involved. Let me... This one passes. That's fine. Should be function call. Let's see what this type is. I'm going to change this to 5 just briefly, and just so we'll get an error. Oh, I should just run 1. I want to see what type it claims it has. Okay. Variable plus error is not equal to function call 3.4 error. Yeah. Okay. My contention is this function call really should be, its type should be number. Wow. Okay. Well, when we create a parser, we pass in the string. We don't pass in the symbol table. We got all this stuff, but we don't have access to those curried runtime functions with their types, more to the point. All right, let me put that on the top here. Function call should not return unknown. That is done, but there's more to come. Okay, and then we need to use Elm type. Well, we added okay. I want to use that in primitive functions. I think up here rather than taking these 3 types, I think you should just take a type. Okay. Well, no, he kind of wants that like that. I was thinking about wrapping curry up here, but that's not really what it's doing. It really is peeling them apart and doing them one at a time. Okay, so let's. I don't think I changed much here. We're expecting the same failure. Okay. Let me just push this change on primitive functions. Not a whole lot there. Okay. Now, where's interpreter? So I guess the deal is well, I think we're going to assume this for the parser. I guess it's a global entity. This is really just for these arithmetic things, because other stuff that you define, that's more runtimey, I think. Precedence parser. Okay. Custom types. Well, that probably should go in the symbol table thing too at some point, but let's just start here. Okay. So we have at least our operators. So our test is still failing, but now we have a way to do it. Let's look up variable. When you create a variable, well, when you reference a variable, see here, evaluate, we have the symbol table and everything's fine, but at this point, when we initialize it, I think, let's see the callers. Well, lots of tests. Right, so in the tests, many of them will have the type, lots of them won't. But variable name, I feel like we need to pass the symbol table in here. Right, so this is all toward passing this test. I'm saying you should have a symbol table. Is it always required? Maybe the type is not required. And maybe you don't need the symbol table. You just need to know if it's in the symbol table, what's its type? Right, that would let us get by more simply. If it's in the symbol table, it's got a type. If it's not, it's generic. I think that's okay. Yeah, let's see who's creating this. Okay, post order tree creates that one. Right. And definite, everything else is tests. Okay, so the two real uses are these two. Okay, and so I'm saying the expression on a variable, lowercase name, there it is, variable, we want to do a symbol table dot type for name. And we know symbol table, but it doesn't have a type for. Okay. Let's go to symbol table. Right. Okay, so function type for name of type string is Elm type. Okay. And if we return, can I say dot generic? Okay, because it knows it's Elm type, I guess. I never quite know. Parser. So right now, this should act the same. I don't know where that lowercase name thing went. There. Okay, symbol table dot type for name. That should be fine. The other place was post order. Right. And what does he have? Well, he almost needs the symbol table. Okay, if we run this, this should be functionally the same. Everybody's returning generic like they do by default. Okay, that should be the same failure we've been seeing. Parser Tests. This expression, yeah, because we don't have this case covered because that comes from post order. All right, let's find who creates post order. Callers. Parser.operator expressions. Okay. Right, so he can take a tree. So I got to get my to-dos lined up here. So we have these obligations we're giving ourselves. So one is parser. Well, one is symbol table dot type for. Okay, needs direct testing, I guess I'll say. The other thing is parser looks up type for variable, and then post order uses symbol table. All right, and then post orders callers, think there was a few tests. Oops. And one usage. Right. So I think we could say a symbol table goes in okay, so symbol table, we'll type symbol table, and that thing equals, if we default the value, it may help us a little bit. He takes an inner and initial values. We can give it an empty list. We can give it nil and an empty list as a default. I hope. Okay. I think I can do this maybe. Okay, and now parser, he passes precedence table dot parse result with the symbol table. Okay. I'll probably have some breakpoints lying around. I was kind of hoping that would do it. Parser tests. Successful test. What's he got? Function call 3 plus 4, number 5 is not equal to error 5. So let's go back here. Oh, I guess parser tests. What test were we working on? It was 3 for this one. Okay. That passed. That's the one that should not have passed. Okay, so function call plus 3, 4. Does function call get a type? He does not. Okay. Well, let's stop. Well, I think we have to be... The problem is we're not explicit here. I mean, honestly, we have to do this again. That should be our expected value. This variable of type function type, that should be the type coming in. All right, let's run it and then we'll debug it. Yeah, because it's not going to work, right? Okay, let's see what we got. Function call variable plus 3, 4 of number is not equal to a function call variable 3, 4 plus error. Well, this function call definitely should have type number. All right, let's go in our parser. We're looking for these. Well, we're kind of here. Post order of tree. Okay, so let's run the same test. And should take us to post order of tree. Oh, didn't stop. 3, 4. Let's stop here and let's stop here. Oh, variable doesn't look it up. Right, we didn't save it. Okay, ding. let symbol and save it. Right, and now use it variable with symbol table dot type for, well, let's dig out the name. Let operator equal So we're going to use the symbol table, look up the type, and create a function call with the variables. Excuse me. Sorry, top secret sneeze, excuse me. All right, we got the variable, the operator name. We look up the operator's type and use it. That seems more promising to me. Now, I don't know why two things would break. Probably, well, I don't know. I would hope one or two would start passing. All right, and I'm just going to continue. Boom. Okay, interesting. Let's put this back on. That thing blew up. Okay, let's run that test again. I was hoping you were going to stop. You called a tree. How could you not stop? Well, let's pause here too. Parser tests. Parses as function call. How are you never calling post order? That doesn't seem possible. Result count is 1. Well, let's stop here too. I don't know. Okay, let's look at expressions. Let's look at result. Nothing yet. All right, we'll step over. Okay, result. Expressions has 3 values. Wait, result has 1? One. Oh, it's not an operator. This is a function call. I'm a little puzzled. His type is error and he's got 3 values. That seems good. Function call, operator expression. I guess we want to stop down at expressions. This is handling the infix operators. We don't have any infix operators. Okay, we are coming into expressions. Function call of expressions. Okay, let's stop here and not stop here or here. Okay, so expers. Plus with the type generic, so he didn't get looked up. Or he didn't get found. Let's see where he's getting looked up. So that should be variable, lowercase name, symbol table type. All right, let's stop here. Oh dear. How did we get here? Where's my prefix operator? Oh, okay. No, I don't know. I don't like working on one failing test for, half an hour or whatever. Okay, now let's look at expressions. Generic still. All right, I'm going to have to break here too. Okay, there's the prefix operator. We'll step over this one, into this one. Oh. Okay. How embarrassing. Let's see. So we got to look it up. Oops. Must be unwrapped. Oh, that's probably... Can I do with that? Self, subname. Otherwise, generic. So look up self, look up name. If the name exists, return its type. Otherwise, just return generic. That seems right. And maybe I should have stopped and tested that guy in place first. All right, running all tests. I will just skip any breakpoints. Boom. Test expression with operators. Well, I don't know what the issue is. Let's see. This is test expression with operators. I'm gonna I just want to see who else is blowing up and what's going on. I really like this one to pass. Everybody's having trouble with allocating post order. Clean and rebuild. I don't know if there's some issue around passing the symbol table in. I don't see why that would hurt. I mean, this thing gets allocated once per expression, once per arithmetic expression. All right, well, whatever it does, one way or the other, we're going to stop here. We'll pick up tomorrow, 1 to 3 p.m. Eastern time, and I'll probably revert to that a little bit and see what's going on, but I'll save the work for tomorrow. All right. Thanks for joining me today, and hope to catch you in the future. Bye-bye.